Okay, Algebra 2. Today we'll do lesson 9-6, solving rational equations. This will be the last assignment that you guys will have to do before spring break. I was going to do a worksheet, but no, I'm not going to do that. I'm just going to go ahead and just give you this assignment. So basically Wednesday will be a work day for you guys to get her all done and then to get anything else that you need to caught up. So, solving rational equations. When you have equations set up like this very first one, which is going to be the first few problems that you guys are going to have to do, keep in mind when two proportions are set equal to each other, cross multiply to solve. Okay, so you're going to have -4 times x plus 2 equals, I'm going to go ahead and take my 3 times my 5 to get my 15, x plus 2. Okay, so distributive property, -4x minus 8 equals 15x plus 30, distributive property. Okay, I'm going to add my 4x over. So I got -8x, or -8 equals 19x plus 30. Subtract my 30 over. Come on up here. So I get -38 equals 19x. Divide by 19. X equals a -2. Okay, so that's the solution I got. Here's the problem. If I were to take that -2 and put it back into either one of those equations, what would happen to my denominators? 0. You can't divide by 0. Therefore, yes, we got it as a solution. And remember, when you have something as a solution and it doesn't work, it makes it an extraneous solution. Okay, so that would be an extraneous solution. Okay, again, means I got a solution because I did, but it doesn't work when I plug it back in. And this is something that I just helped a college algebra student with for their one test, and that was making sure you're checking for extraneous solutions. Because when you're looking at it at the college level and you're looking at a multiple choice test, they're going to give you that as an answer, and it's just not an answer. It doesn't work when you plug it back in. So always check those denominators, and you're going to do that on these, on the rational equations. Take those 2 numbers or 3 numbers, however many numbers you get, plug them back in, make sure that denominator doesn't hit 0. Okay, that is key. When you get down to problems like these ones down here, okay, make sure you find, because I want to clear my fractions. Excuse me, always clear your fractions. So, in order to clear the fractions, you need an LCD. So on this one here, what would my least common denominator be? My LCD. Well, I look at my numbers. 3, 3, 5. What number does all of those go into? 15. And an x. They each have an x, except for this one. So there's your LCD, 15x. We're going to take it and we're going to multiply it to every single term. Okay, to clear those fractions. We're going to multiply it to every single term. All right, how many times does 5x go into 15x? 3. What's 3 times 3? 9. I just cleared that fraction. Did I change the value of this equation? No, not at all. Just because I'm clearing the fractions doesn't mean I'm changing the value of that equation. This one here, how many times does 3x go into 15x? 5. Because the x's cancel, 3 goes into 15 5 times. What's -4 times 5? -20. I just cleared that fraction. Equals 3 goes into 15x, 5 x times, because you got that x left over, that x didn't cancel. 5x times 1, 5x. Simplify. What's 9 minus 20? -11. equals 5x. Divide by 5. Negative 11/5 equals x. I'm going to check. Nope, doesn't make my denominator 0. There's my solution. So no extraneous solution on that one. So again, find that LCD and clear your fractions on those. And I'm going to do a few more examples, so don't panic. I'll do a few more examples for you guys. All right, flipping it over. Another example. Your LCD on this one. Well, what's your only thing in the denominator? An x. So my LCD would just be x. So I'm going to take every single term, I'm going to multiply it by x. X times x, x squared. 6 over x times x, the x's cancel. Equals a negative 5x. Combine onto one side, so set it equal to 0. X squared plus 5x plus 6 equals 0. And then we are going to factor. Factors of 6, if I add them, they give me 5. 3 and 2. So what are my two solutions? X equals negative 3. X equals a negative 2. So I look up here, my denominators, nothing's going to clear. So both of those would be possible real solutions. So don't make these difficult. Clear those fractions, and they're actually not too bad to solve. When you get down to problems like 27, and they want you to solve for variables. So on 27, they want me to solve for, they have a little semicolon in E. So first thing I'm going to do is I'm going to add my 1 over MC over. So I'm going to have C over E equals 1 over MC. Cross multiply. So I'm going to have MC squared equals E. Did I just solve for E? Did. Done. You're not trying to find a number. You're not trying to find the solution. You're just manipulating the formula. And a lot of these you're just going to be trying to get them into proportions and then cross multiplying and solve. Could I have multiplied every single thing by E, MC, because that's my least common denominator? You betcha I would have gotten the same thing. This was faster. This was 2 steps. If I took it by E, MC, it would have been 3 or 4 steps. Okay, so I always try to go with the easiest that I possibly can on those. Okay, a couple more. So this one here, your LCD, is just going to be, if I were to factor this, b plus 1, b minus 1. So my LCD is b plus 1, b minus 1. So I'm going to take it b plus 1, b minus 1, b plus 1, b minus 1, b plus 1, b minus 1. Here the b plus 1 cancels. So what am I left with? B minus 1. Here the b minus 1 canceled. What am I left with? B plus 1. Here the whole thing canceled. What am I left with? 2. From here we solve. B plus b, 2b. Negative 1 and 1 is 0. So what does b equal? 1. I go to plug it back in. Look at what happens right there. 1 minus 0. This right here is extraneous. That means that there is no real solution to that problem. That's an extraneous solution. Okay, last one. This one down here, if I factor that, x plus 5, x minus 5. What am I going to do to this one here? I'm going to do one thing. I'm going to make this negative and then switch the signs on both of those. So then I've got an x minus 5. So now my LCD is x plus 5, x minus 5. X plus 5, x minus 5. X plus 5, x minus 5. So here what cancels? The x plus 5. I'm left with 3x minus 5, so I'm going to distribute that through. 3x minus 15. I just took the 3 through. Sorry, that was through 3x. So I just took the 3 all the way through. 3x minus 15. Here, the x minus 5. X minus 5 cancels. So now I'm going to take my negative 2 all the way through. And again, why that's negative is because I switched the signs on all of these to make it so it was easier to see how to cancel it. Take your negative 2 all the way through. Negative 2x minus 10 equals, the whole thing cancels, negative 4. Solve. 3x minus 2 is x. Negative 15 and negative 10, negative 25 equals a negative 4. We're going to add 25. X equals 21. Plug it back in. Yeah, it works. So therefore, that is a real solution. It's not extraneous. That would be my real solution. So those are the types of problems that you're going to do on that lesson. It's not too bad. Okay, just make sure you're finding that LCD and you're clearing those fractions. You should not have fractions. If you're clearing correctly, you should not have fractions anymore. And then it's just easy to solve from there. Then you're down to basic algebra from there. Okay, so there it is. Lesson 9-, what was it, 6? Yep. Lesson 9-6. Rational equations, rational expressions. That'll be your last assignment before break. Have a very good Easter break. And I will talk to you guys on Tuesday.